Audio Jungle. Audio Jungle.
Hello everyone, myself Singh Maurya and hope you all are doing well. Guys, today we'll solve GATE 2020 problems. Now this is problem number 25. Here that question will read an airplane of mass 5000 kg. So that mass it is given flying at a constant speed of 360 km per hour at the bottom of vertical circle with a radius of 400 meter as shown in the figure. Assuming that the acceleration due to gravity it is given g is given, the load factor experienced at the center of gravity of the airplane is. So basically here they are asking what is the load factor. So we'll write all the given value. It is nothing but mass 5000 kg, velocity it is given 360 km per hour. You convert into meter per second, so you just multiply by 5 by 18. How much you may get? So it is 100 meter per second. All right. Another value they have given radius, so we'll write radius is nothing but 400 meter. All right. G they have given 9.8 meter per second square. These are the given data. Now here they have mentioned the aircraft is what flying at constant speed of 360 km per hour at the bottom of the vertical circle. So basically turning we have two types of turning. Okay, I will write here turning flight. Okay, we have two types. One is on vertical plane, another is what on horizontal plane. So this problem is what based on vertical plane. So it is on vertical plane. So basically vertical plane, and it is the circular uh, form of the motion. So you can say this is the aircraft here. Okay, aircraft is here only. Just check the diagram. Aircraft is what here. This is the aircraft. So obviously weight will be acting downward and lift will be acting in upward direction. All right. So if you check the resultant upward force is nothing but Fr, which is nothing but L minus W, because that aircraft is what on bottom of the circle, so L minus W. So this L minus W, because it is not circular motion, because I have mentioned this turning flight on vertical plane, so it is almost circular motion. So this circular motion, two types of forces will be acting. Okay, one is this resultant force, which is nothing but in upward direction, L minus W. Second one is what centrifugal force. Okay, centrifugal force, and centrifugal force will be acting away from the center. And what will be the force? That will be nothing but mv square divided by r. All right. So these two forces must be equal. Okay. And this centrifugal forces, basically whatever the centrifugal force we have, it will be acting away from the center. So suppose this is the center, so this force, resultant force, will be towards the center. Okay, this is the towards center, I can write, and this is away from center. Centrifugal force is nothing but away from. All right. So you can write this at equilibrium. At equilibrium, what will happen? This resultant force Fr is equal to centrifugal force, which is nothing but mv square by r. right? Very simple. Now we'll use this concept. Data they have given, so Fr is nothing but resultant force, which is nothing but L minus W, which is nothing but mv square by r. Okay, as in this problem what they are asking load factor. So what is the load factor? Simple. What is the load factor? It is denoted by n. Okay, it is denoted by n, and it is nothing but lift force divided by weight of the airplane. Lift force in airplane, weight of the airplane. Okay, what is the lift force generated in airplane? It is L, and weight is nothing but W. So basically n is equal to L by W. This is nothing but load factor. We can write this n is equal to L by W value in this equation number 1, and this is what equation number 2. So we'll relate this. So what we'll have, L is equal to NW. So we'll write NW minus W is equal to mv square by r. All right. From here you can check this. We can write this n value here in this resultant value. So we can write W n minus 1 is equal to mv square by r. All right. Anyway, so here we know that velocity or speed is 100 meter per second, radius 400, g 9.8. So everything basically here it is given. Now unknown is what? N only. So we can calculate this value. So what we can write? W n minus 1 mv square by r. You can write this mg n minus 1 again cancel out. What n minus 1 is equal to? So what will be n? You can write this v is nothing but 100 meter square, r is 400, 9.8 plus 1. 100 square divided by 400 into 9.8. This value will be, if you calculate, you may get 2.55, and this is what? Plus 1. So how much? 3.5. This is the n value. Load factor, we don't have any unit. This is dimensionless. So here, check. That's the reason they have not given any unit. So that answer will be 3.55. This is the answer. I hope everybody understood this. All right. Now we'll go for next problem. I hope you all understand this. Any doubts you may get, then you can write message in comment box. So I will reply earliest. Okay. Anyway, now this is the next problem. Problem number 46. All right. So here again, you just check a single engine propeller driven, mentioned here properly. So propeller driven general aviation airplane is flying in a cruise at sea level condition. Remember, it is sea level condition, so obviously density will be sea level density 1.225 with speed to cover maximum range. This is very important points here. It is mentioned maximum range, so you have to remember this point because that problem will be solved based on this given statement. All right, so for drag coefficient, so this is basically called drag polar, and wing loading they have given. So wing loading, I already in previous session I explained, right? Wing loading is nothing but weight of the aircraft divided by plane form area of the wing. Okay, the speed of the airplane is, so basically they are asking the speed of the airplane. So what they have given data, you write it. So given data, very important mentioned, it is propeller. Propeller, it is mentioned in problem. Always remember. And given data is density at sea level, so rho naught 1.225 kg per meter cube. With speed cover maximum range. It is propeller driven, and another given in given data we can write also maximum range, it is mentioned. Okay, in your problem this is also very important. Two statement, based on this we have to solve the problem. Then another thing, they have given drag polar. What is the drag polar? They have given 0.025 plus 0.049 CL square. All right, and wing loading, it is denoted by small w, and that is the ratio of w by s, means weight of the aircraft to the planeform area of the wing, which is nothing but 9844 Newton per meter square. So these are the given data here. All right. Now what we have to calculate? We have to calculate the speed of the airplane. Speed of the airplane on which condition? Two conditions they have given. What are the conditions they have given? I told you, need to remember, for the propeller driven aircraft and for the maximum range condition we have to calculate speed. So we can write, calculate, okay, our calculation for speed of propeller driven airplane at maximum range condition. I am going very slow while I am solving the problem so that easily you can understand, but in your exam you have to do rapid. Okay, you have to perform fast calculation. No need to write every things here directly. You need to read problem, understand the things, and write formula and finish it. Okay, here I am going very slow so that you can understand easily. Okay, so speed of the propeller driven airplane at maximum range condition we have to calculate. That is our job to do. All right, now, so here in this case we should know what is the propeller driven range formula. So I will write range. Okay, you write this formula, you need to remember range formula. Formula for propeller driven airplane. If you remember, maybe 2020 or 2021, they had asked same question, range formula based question or endurance formula based question, but for jet engine. So I told you many times, like for jet engine and for propeller driven engine, range as well as endurance formula will be there, but it will be different condition and different cases will be there for both uh, propeller driven as well as jet engine. If I say jet engine and propeller driven engine, range formula will be same. So no, formula will not be same. That is my point to say. All right, I mean, for range, for propeller driven as well as for jet engine, range formula will have a different formula. All right, and that different formula you need to remember. Similarly, endurance formula for the propeller driven as well as jet engine, endurance formula will also be different formula. Hope you understood my point. All right, so now we'll write range formula for propeller driven airplane. So range is equal to 1 upon, it is propeller driven, so you have to write cp. Cp means, just like for jet engine it is ct. Ct means thrust specific fuel consumption, so cp means power specific fuel consumption. That's the point, because for the propeller driven engine or a turboprop engine or a piston prop engine, you have to talk about the power, not thrust. All right, so that's the reason here we are writing cp, means power specific fuel consumption. All right. Now, so that formula will be CL by CD ln W naught by WS. What is W naught? Initial weight. What is WF? Final weight. Okay, how to calculate final weight? It's very simple. Final is nothing but initial W minus W fuel, means whatever the amount of the fuel is burned, if you reduce, then you will get final. That's the mean of it. CP is the CP is called power specific fuel consumption, PSFC, power specific fuel consumption. This is the formula. Here they are talking about the maximum range. So if you write maximum, then what condition you may get? Everything will be constant, CP will be constant, W naught WF is suppose constant, so it will comes to directly CL by CD. So for maximum range, this CL by CD must be maximum. What is the CL by CD maximum case? Anyone? I explained in my previous class also. If maximum range or maximum endurance they are asking, then you need to check that variable. So variable means CL by CD you need to check, because CP and weight all are constant. All right, so CL by CD you need to check. If it is maximum range, so it means CL by CD must be maximum. CL by CD must be maximum, it means it is the minimum drag condition. Always remember, it is minimum drag condition. So what is the point comes? Point is speed you have to calculate at minimum drag condition, which is called VMD. All right. So actually you need to calculate. You need to write here speed at minimum drag condition. All right, which is denoted by VMD. So what is the VMD? Simply you need to write the formula for this. What is the formula? If you know, for steady level flight, it is L is equal to W. So it is nothing but half rho V square S into CL is equal to W. All right. Or you can say it is nothing but V 2 W rho S CL. This will be the formula. If I say this is VMD, minimum drag condition, so weight will not be changed for minimum drag condition, density will not be changed because it is sea level density, density will not be changed for minimum drag condition, area of the wing will not be changed for minimum drag condition. These are the constant, doesn't matter whatever the condition, it is minimum drag or minimum power. Okay, so W rho S2, these are the constant value. Only if you say minimum drag condition, so this CL will come for minimum drag condition. So it is called CLMD. How to calculate CLMD? From the drag polar, you know very well. For drag polar it is given. How much it is given? You see, CD is equal to, I think it is 0.025 somehow, 0.025 plus 0.049 CL square. So this is the value. It is 0.025 plus 0.049 CL square. So what is the CLMD? Means minimum drag condition. What is the lift coefficient at minimum drag condition? This is CD naught by K. This is the derivation. Many times it is, you already have seen in many books and your class notes, and in my previous lectures also already I have explained how to calculate lift coefficient for minimum drag. So and how to derive this. So derivation is not required during your, once you go for the revision, or once you go for the practice, and once you go for the solution for any problems, every time don't derive, you should remember this type of formula, right? So this is the formula you need to remember. For minimum drag condition, lift coefficient is CD naught by K. So here this is the drag polar, and this drag polar is nothing but CD naught plus K CL square. This is the format. So what is the CD naught? It is 0.025. What is K? It is nothing but 0.049. You need to calculate the CLMD. So what value you may get? CLMD approximate you may get 0.7142. In my calculation, I am getting this. All right. So this is the value CLMD. Now you just write the value and you can calculate what is the VMD. So VMD is 2 W by S, because minimum speed you need, speed at minimum drag you need to calculate at sea level, so sea level density should know, and this is what CLMD. So just write in root. Check 2 into what is W by S? It is the wing loading, and it is given. How much it is given? Wing loading 9844. 98. Density you know 1.225 at sea level. CLMD just now you have calculated how much it is, 0.7142. Just now you have calculated, right? So you take root of it. If you do that, so this value approximate to 150. You just perform calculation. Let me check once. 29,844 divided by 1.2. You can check the calculation. Root. It is 150. 150.01 meter per second. All right. So you need to perform this, and your calculation speed should be very high. Okay. Here, because I'm giving the solution, so I have enough time, right? But for you guys will not get more time, in fact, while you are doing the calculation also. So better you perfect more and more so that you can get good accuracy, because accuracy you will get when you have so much practice in numerical, right? If you practice more and more, so automatically your speed as well as accuracy you may get, no doubt. So this is your answer. Again, anywhere, if you any steps if you are not able to understand, you can write comment in comment box, so surely I will reply for, okay, for you, don't worry. Now this is the another problem here. Sorry. Now check. So this is problem number 54. All right. So read this. An airplane of mass 4000 kg, all right, and wing reference area, means plane form area, reference area 25 meters square, flying at sea level, has a maximum lift coefficient of 1.65. Assuming density of air, this is sea level density 1.225 kg per meter cube, and acceleration due to gravity is 9.8 meter per second square. Using factor of safety, they have given 1.25 to account for additional unsteady lift during sudden pull-up. Okay, this is the pull-up. The speed at which the airplane reaches a load factor of 3.2 is. So here also they are asking speed, but at what condition they are asking speed? They are asking speed at which the airplane reaches a load factor 3.2. So for that particular condition, pull-up condition, this is the maximum load factor 3.2 they have given, and they are asking, okay, for this maximum load factor, what will be the speed? That is the question. Again, they had mentioned sudden pull-up. So as I told you, pull up and pull down, it is the vertical turning condition for the aircraft. Okay. So basically that aircraft is what, suppose this is the actual condition of the aircraft, all right, and this aircraft is what going for the sudden pull up in this way. This is the sudden pull up. So suppose aircraft is what now here. For this condition, they are asking speed. You understood? This is the uh, level condition, but here this is the vertical pull up. Huh? Sorry. All right. Yeah. Anyway, so it's a simple only. The thing is, you need to understand the condition, and what condition they have given reaches a load factor. It means this load factor will be the maximum load factor n max, and working load factor they have not given, but yes, factor of safety they have given 1.25. All right. So from this factor of safety you can calculate what is the working load factor, because this is the maximum load factor. They are asking the speed at which the airplane reaches a load factor of 3.2 is. All right. So in this case, you will calculate the working load factor. Maximum lift coefficient they have given. So okay, we'll write all the given data first. Mass they have given 4000 kg. S area they have given 25 meter square. CL max. CL max is the maximum lift coefficient, which means when it will give, when they are interested to know what is the minimum speed, okay, a minimum speed required to sustain the flight, at that time what is the lift coefficient, it will be the maximum lift coefficient. That is the mean of it. So whenever maximum lift coefficient they are suppose giving, so that meaning is what they are asking, like what is the minimum speed required to sustain flight condition for the aircraft. All right, so minimum speed, you can easily, minimum speed also called as a stall speed, that you know. All right, so with the help of maximum lift coefficient you can calculate what is the stall speed or minimum speed. That's the one point. Here what is the things we'll see according to the condition. Sea level density, it is denoted by rho naught 1.225 kg per meter cube. Factor of safety they have given, factor of safety they have given how much, 1.25, okay. And n max, which is nothing but maximum load factor, they have given 3.2. They're asking speed as the, okay, so speed v they are asking. We calculate this, it's simple only. All right, so this speed we should calculate of v. Anyway, so as in mechanics of uh, solid, which is also called strength of material or solid mechanics, so there you have seen one formula, which is which is that formula was related to factor of safety, but it was related to the load. So we'll use that concept. That is nothing but, what is the factor of safety? It is called ultimate load uh, divided by working load. Ultimate means maximum, how much amount of the load, means maximum load you can give to any body or any like a component, so that they it can work. After that it will fail, so that load will be called as a ultimate load or maximum load. And working load means what is the currently working, or at normal condition what is the load applying to that component, so that easily it can work. So working load and maximum load are both are safe condition, but more than maximum load, if any component if you give, then it will be failed. But more than working load if you give, then it will not fail, but it will work. But there, like there are condition, I mean at that time you should know what is the factor of safety, because if you don't know factor of safety and continuously you are increasing load to that component, so uh, when and what, at what condition it will fail, you may not know. So for that reason factor of safety is required. I mean factor of safety is the one reason of the load, okay. Up to that component where the load is what applying, up to that component will be safe. Okay, so I can give the one thing, like suppose this is the working load to maximum load. Okay, so up to this range component will be safe. That's the mean of it. Component will be safe. That's the reason it is called factor of safety. But if you go more than this, then it is danger. It is danger for the component. I mean that component will be failed. That's the mean of it. Okay, so that's the reason factor of safety is nothing but maximum load divided by working load. So similarly, that factor of safety in our case, we don't have load, but we have load factor. And that is also the one kind of the load. Okay, so we have to write this factor of safety in terms of load factor. So factor of safety is equal to, you can write maximum, we can relate this formula maximum load factor, because they have given load factor here for us. So maximum load factor divided by working load factor. We can write this maximum load factor, how much they have given. uh, it is 3.2 and factor of safety 1.25. Okay, sorry. So maximum load factor they have given 3.2, and working load factor we need to calculate this. Okay, and factor of safety they have given, it is 1.25. It is given, na? So we can calculate what is the working load factor. So working load factor we can write here, it will be working load factor, n is the work load factor, and working load factor or safely working load factor. So safe working load factor I can write nsf, sorry, load factor ns. Okay, that is the working load factor or safe uh, load factor. Or okay, so I will write here better, safe load factor, sf. Now it is fine. Okay, sf means safe load factor. So how much you may get? It will be 3.2 maximum divided by factor of safety, which is nothing but 1 point, I think it is 1.25, right? 1.2. So that value will calculate how much it is. We'll see. What is the factor of safety? Yes, 1.25. Anyway, so we can calculate it is 3.2 divided by 1.25. So we'll get 2.56. Need to remember. Okay. Now we have to calculate that speed during the sudden pull up. So if you say pull up and sudden pull up, so a different word. Pull up, pull up or pull down, that is the different case. At that time you need to write that resultant upward force is equal to centrifugal force. That is true. But here it is saying sudden pull up, so it is very short time of period, so it's a time instant. So in time instant directly you can write uh, it is the sudden pull up. Okay, otherwise if it is pull up or pull down vertical turning, so that resultant force will be L minus W is equal to centrifugal force. But here because it is sudden pull up, so exactly L is equal to uh, W, but it is the sudden pull up, so you need to write N. Because L is equal to W, if you are writing, it means it is a steady level flight. L is equal to W, but it is not a steady level flight, it is sudden pull up. So for time being it is going for the pull up condition, so hence you write L is equal to NW. Alright, and N is the now safe loading factor. Hope you understood. Now you can equate this and write all the formula, half rho V square S into CL, and NSF into weight. Weight they have given, I think. Let me check. Just weight they have given, mass they have given, no problem. And G also they have given. So we'll write all the value. W they have given, so we'll write mg. Alright, so velocity or speed they are asking to us. So NSF into mg divide by, okay, 2 will come also, okay, divide by rho at sea level, and S will come and CL will come, and CL they have given maximum, so obviously this speed will be minimum. Okay, and so what is the minimum speed? And this minimum speed also called V stall. If you have seen VN diagram, so this was V star. Okay, so now it is clear, because CL max they have given, it means obviously everything, like you have calculated safe working load factor, mass is constant, G is constant, density area is constant. So if it is CL max, so it means velocity you may get minimum. This velocity also called corner speed. What it is called? Corner speed. And obviously this is also called stall speed. So different name at different places, but meaning is same. Okay, if you write all the value, you know, mass, gravitational acceleration, density, area, so you may get that value. So I will write here, this is nothing but V star, anything you can write, V stall. Okay, V mean, so 2 into SF, just now you have calculated 2.56, 2.56, mass is 4000, I think 4000, G 9.8. Okay, write all the correct data. Density is 1.225 sea level. What is the area? I forget. Area will check. 25. 25. Yes or no? This is the 25. What is the CL? It is 1.65. Take root of only the things. All right. Check. Hmm. Okay. Calculate this. So you may get V star. It is approximate to 63.02 meter. As per my calculation, this is the value. Okay, you check it, calculate, cross check, and this will be the solution. Again, on any step, maybe if you are getting any doubt, so write comment on comment box, and I will reply soon. Okay, thank you. We'll go for next problem. This is the next one. Check. I think this is the last problem of this GIT 2020 performance problem. Okay, so check here. This is question number 55. See, now a pitot tube mounted on the wing tip of an airplane flying an altitude of 3 kilometers. So we have aircraft here. Suppose this is what sea level. So 3 kilometer altitude it is flying. All right, we just listen this. Measure a pressure of 0.72 bar. So if pitot tube will measure, so obviously it will be a total pressure, no doubt about it, because pitot tube will basically used to measure total pressure. So here we have pitot tube, and many times pitot tube is what installed on the main wing. You may have seen, might be fighter aircraft and all, or sometimes on vertical tail. It should like at a place where fresh air are coming and hitting to the pitot tube. I mean, it can enter, fresh air can enter, so that it will specific place. Undisturbed air should be there. All right. So I will show you. This is suppose pitot tube here maybe. Hmm? This is the pitot tube anywhere. Maybe installed here pitot tube. Or sometimes here, any place, not every place. Sometimes here, maybe pitot tube they can place here, or sometimes here also on vertical. Remember, not horizontal plane. This is the horizontal, right? And vertical is what here. Hmm? This is the horizontal plane. Hope you understood this. Yes or no? So this is the pitot tube. So pitot tube is what measured total pressure. How much? 0.72 bar. This value it is given. Hope you understand. No? Altitude it is given h is equal to 3 kilometer. So, and outside air temperature is 268. Remember, see, this is not 288, this is 268. It means they have given temperature at 3 kilometer. Outside air means where it is flying at 3 kilometer. So 3 kilometer temperature is given, that is 268.66. So I will write temperature at 3 kilometer, it is 268.66 Kelvin. All right. Take sea level condition as pressure. So sea level condition pressure they have given P naught, it is 1.01 bar, and at sea level, sea level temperature here it is given T naught 288.16 Kelvin. All right. And sea level density also they have given 1.225 kg per meter cube. They have given G 9.8 meter per second square, and the gas constant R also they have given how much, 287 joule per kg Kelvin. Assuming standard atmosphere, they are asking equivalent airspeed. Equivalent airspeed VEAS. This is the equivalent airspeed in meter per second they are asking. Okay, in meter per second they are asking. Right, it's a very nice question. So what we'll do here, just listen carefully, you may get the idea. It's very nice question. Okay, equivalent airspeed, you can calculate. What is the difference between true airspeed and equivalent airspeed? True airspeed means you have to calculate speed of the aircraft at with respect to the density at that altitude only. Means at 3 kilometer only, what is the density? That density if you use, then it will be true airspeed. But equivalent airspeed means even though it is flying at 3 kilometer altitude, but you have to use sea level density, then you may get equivalent airspeed. So for equivalent airspeed, sea level density is required. That is my point. Hope you understood now. All right. Anyway, so we'll first of all we'll write the formula, like how to calculate equivalent airspeed. So it's a very common thing. Like you write the pressure formula. So what is the total pressure? You know what is the total pressure is equal to, this is the Bernoulli equation only, static plus dynamic pressure. I mean static pressure plus dynamic pressure. Total pressure here it is denoted by P naught. Static pressure is denoted by PS. Dynamic pressure is denoted by PD. Okay. So P naught is equal to PS plus dynamic pressure is half rho V square. So from here if you write what is the V, it will be, check P naught minus PS. This is P naught total minus PS. Okay, to check the, you may get automatically. So this will be the value. If it is equivalent airspeed, I told you, then this density should be sea level density. That's all. This is the now formula. This is the formula now. So you should know what is the P naught pressure. So yes, here it is given P naught. I'll change the color so it will be more clear. So P naught is given. All right. Check PS is given at 3 kilometer PS. I mean static pressure is given. No, it is not given. It is not given. Only temperature they have given. They have not given static pressure. If you check this 1.01 bar, so this is not a 3 kilometer pressure. This is at sea level pressure. So what is your next job? Because in this formula, whatever you have derived for the equivalent airspeed, so here that formula is P naught and PS. Okay, P naught is given total pressure and PS you need to calculate. So what we have to do? We need to calculate. We need to calculate sea level pressure. Okay. So you should know this is, suppose sea level. This is the sea level, and this is what, 3 kilometer altitude. Okay. So at H distance, what is the H? 3 kilometer. So this is from basically 0 to 3 kilometer. This zone is called troposphere. I hope everyone aware with this. Okay, 0 to 3 kilometer it is called troposphere. So if you want to calculate What is the pressure or temperature in troposphere? So there is one formula. I mean, for the pressure one formula, for temperature one formula, and for density also one formula. Okay, that is called governing of equations for the pressure, temperature, and density in troposphere. And troposphere is from 0 to 3 kilometer. So here I am going to use that formula directly. Okay, but it is the one derivation here, as I mentioned. Once you go for the solution of the gate problems, so don't go for derivation every time. One time you need to do, and that you can watch the another lectures. So I will be giving that derivation, but here I am going to use the formula directly for the troposphere, for the pressure calculation. All right, so here I will write, you just check it. So for that formula, pressure formula, no? You please remember this formula, pressure formula in troposphere, because troposphere formula is different and stratosphere formula is different. So troposphere, if you want to calculate pressure at 3 kilometer, so you should know pressure at sea level is equal to, you should know temperature at 3 kilometer divide by, you should know temperature at sea level, to whole power g by lambda r. What is the lambda? Lambda is called lapse rate. For the troposphere, what is the lapse rate? It is 0.0065 Kelvin per meter, or you can write 6.5 Kelvin per kilometer. This is the lapse rate. R they have given to you. And check all condition temperature they have given. They have given temperature at 3 kilometer, as well as they have given temperature at sea level. Both temperature they have given to you. Directly you have to use. Okay. So I will write there. And pressure at uh, 3 kilometer they have given to P naught means uh, this is the total pressure, sorry, this is the total pressure, and sea level pressure they have given to you. Check, this is the sea level pressure. So 3 kilometer pressure you need to calculate. Okay, at 3 kilometer pressure you need to calculate. So P at 3 kilometer, I will write this is equal to P naught, okay, T 3 kilometer divided by T naught, all the value I have to write. What is the sea level pressure? What is the sea level pressure? It is 1.01 bar. No? Check it. It is given. It is given 1.01 bar. So I will write now directly all the value 1.01 bar. So bar I am not going to write. Remember, whatever the pressure value will come, it will be in bar. 3 kilometer. What is the 3 kilometer temperature? It is given, if you check, 268.66 divided by T naught. How much it is given? 288.16. G, what is G? 9.8. What is lambda? If you are writing this value, so distance you have to write in meter. If you are writing 6.5, then distance you have to write in kilometers. So I will write lambda value in 6.5. So uh, uh, that value you can write in kilometer. Okay. So, but here whatever the distance you are writing in terms of meter. Okay, so whatever the value of the lambda standard unit, you need to write kilo per meter, not kilo, sorry, Kelvin per meter, not Kelvin per kilometer. This I will tell you this when you will use this concept. Th is equal to T naught minus lambda h. So temperature at 3 kilometer, if you want to calculate, okay, suppose 3000 meter, so you will write T naught minus lambda. This lambda should be in Kelvin per meter. Then H you have to write in meter 3000. Hope you understood what I'm saying. 3000 meter if you are writing, then instead of H you write 0.0065 into 3000 you have to write. Okay, but if you are writing T 3 kilometer only, so T naught minus lambda 6.5 into 3 you need to write. What is T naught? Sea level temperature at 3 kilometer, you can calculate it. I will show you. T 3 kilometer, check. What is the sea level temperature? 288.16. Okay, minus 6.5 into 3. How much it is? 6.5 into 3. Let me calculate. It is 19.5. It is 19.5. If you write 288 minus 19.5, then it is 268. So this is the formula in troposphere how to calculate temperature. 268.5 Kelvin. Check 268 you are getting here. Yes or no? 268 at 3 kilometer it is you are getting. See this value. I hope you understood. Anyway, so you just write 0. You just write 0.0065. Okay. 0. Just wait. Sorry. 0.0065 into R, because standard unit is meter not kilometer. R is 287. So if you check what is the pressure at 3 kilometer you have calculated. So in my calculation I am getting 0.698. You please check it from your side also, you have to check bar. All right, now pressure at 3 kilometer you know. So this 3 kilometer pressure is what is static pressure for the aircraft at 3 kilometer. Yes or no? Now if you want to calculate the sea level is equivalent air speed, so it will be 2 P naught minus P 3 kilometer, that is called static pressure, divided by density at sea level. Okay, this 3 kilometer means sea level pressure. Just now you have calculated. Check total pressure, what value you had. Total pressure is what? 0.72. All right, so it is nothing but 0.72 to 0.72 minus 0.698 divided by sea level density 1.225. Okay, if you check this equivalent air speed, so as per my calculation I am getting nearby 58. Okay, you also have to check 58.8, which is nothing but you can say it is 59 meter per second. I am getting this value. You check it. Okay, this is the solution for this problems. So again I must say, if any doubt for whatever the problems today I have solved here, any doubt on any steps you are getting, you write comment on comment box, and definitely I will see and I will reply. Again, if it is required, I will solve with different method also available for the problems. Please like it and subscribe the channel, so whenever I will upload the new video, automatically you may get the notification. All right, because this solution videos will be continue, okay, till 2007. All right, so that I'm telling you, just like and subscribe, so once I will upload next new video, then automatically you will get notification for like solution of gate for 2019. Next video will be there, then again you may get 2018, 2017, so that will continuous. All right guys, so do hard work, keep revising the topics, and because gate exam is what very near, like February first week everybody knows, so you continue your preparation. All the best. Thank you.